Hey guys, all right. So lesson 7 is talking about infinite limits and limits at infinity. And so what they've done here at the very beginning, we have two situations. One where you have a limit which is infinite, and you have limits that as you approach infinity. All right. So we've got two graphs here. We've got f of x and g of x, and it's asking us to answer these questions based on both of those. So here we go. All right. So this is f of x, and so it says we have a function here. If you are approaching 4 from the left, that appears to be heading upward forever and ever and ever and ever. My infinity symbol is terrible. And as you're approaching 4 from the right, we're heading to negative infinity. Okay. And likewise down here on G, 1 from the right is positive infinity. And 1 to the left, from the left, sorry, is negative infinity. Okay. And so then it's like, okay, what do you gather from that? Well, from that, we know that both of those were caused by vertical asymptotes. I guess that's good. Vertical asymptotes exist where limits are unbounded. That means you've got an infinity or a negative infinity. All right. And then what do we got going on down here? So now we're approaching infinity and negative infinity on those two graphs. All right. So on f of x, the one up here, as you approach negative infinity, looks like we're heading towards this horizontal asymptote, which is negative 2. All right, and then if you're heading to the right forever and ever and ever and ever, it looks like the exact same thing. But we have another case that can occur down here with g of x. As you're approaching negative infinity on g of x, it looks like we're approaching a line. All right, so it is heading to forever downward. But there's a line here that it appears to be approaching too. So maybe we can talk a little bit more about that. They call that a slant asymptote. All right, and then to the right, looks like we're just heading up forever and ever. Okay. All right, so what could we say? Well, we could say limits at infinity can approach a horizontal asymptote or a slant. In that case, you would have infinity or negative. So I think on that though, it's kind of cool to know that if you did have a slant asymptote, and we'll talk more about that in just a second. So yeah, so a limit at infinity is possibly, oops, not one to type. Oh, get out of that one. Escape, escape. Oh, there we go. That's right. Okay, so a limit at infinity is either unbounded or approaching a horizontal asymptote. Let's try that. There we go. Okay. Okay. So the unbounded thing could be positive infinity, negative infinity. That's what you would answer, like we did right here. Or you could approach a horizontal asymptote, as we did in this case. Okay. All right. Next. All right. And so we've seen these before. When factors canceled from a denominator, this is where there we go. A whole or non-removable discontinuity. Heard. Doesn't like that non-removable. Maybe go hyphenated there. Awesome. All right, and then right here, when a factor would not cancel, you had a vertical asymptote. Cool. Okay. All right. All right, and so use the previous equations to find one-sided limits analytically. Okay, so now we looked at the graphs. These are the exact same two that we saw up here. But now we're going to kind of look at it as if we did not have a graphing calculator or any way to know what it was. And so we're going to do a little factoring. All right, so this one would equal the limit as x approaches 4 from the left, and let's see what we can do. Okay, so I'm going to factor as much as I can in the numerator. So I have -2 that I can factor out, and I'm left with x squared plus x minus 6, not 16. Minus 6. And I'll go ahead and factor that denominator while we're here. All right, and so factors of 8 that add to give you -6.
Good afternoon, Cleveland High School Blue Raiders. At this time, all students should exit the building or be under the direct supervision of an adult. Thank you and have a great afternoon.
Okay, so now we've got the limit as x approaches 4 from the left of -2 times, and this is going to be x minus 2 x plus 3 boom, boom. Okay, now, so here's the deal. All right, so we already looked at the graph and we know, but if I'm approaching 4 from the left, then what that's going to do is substituting like a, I don't know, 3.999, that's going to cause this to be negative. So just a little note here. That's going to be a negative, very small number, all right, into up here, if I use 4 from the left, like 3.99, then that's positive times the negative is negative. All right, so that's what's kind of happening here. It's a very small negative into a large negative, which then is a positive infinity. Okay, now, so that, of course, makes sense when we look at our graph and we say it's coming from the left, it went to positive infinity. Okay, so that was how you do it without the graph. Now, likewise over here, now that I've done a lot of work here, I can just pick it up at this point. All right, so if the limit I've already done all the factoring and stuff. So as x approaches 4 from the right of the same thing, so it's -2 and then an x plus 3. Awesome. Over x minus 4. And once again, like if I'm substituting something in that's greater than 4, like 4.00001, this is going to this will equal, I'll have a positive on the bottom, right? And then a 4 right here. Anything close to 4, larger than 4, is positive times negative is negative. So that's a negative, very small number, very small positive number into a negative number. Then we'll end up being negative infinity. Okay, and so then down here, likewise, we had the limit as x approaches 1 from the left, and a little bit of factoring. So I can up top, I can factor this as I cannot factor that. So never mind. Erase all that. Okay. There we go. Okay, so then, all right, so back to this then. If I try, this will equal, if I substitute something in close to 1, then this would be close to 1 minus close to 2, which is going to be close to -1 plus 5 is going to be positive, right? And then on the bottom, if I'm substituting something very, very close to 1 from the left, so like 0.9 or something. So if I said 0.9 right here, 0.9 times 2 is going to be less than 2, subtract 2, it's negative. All right, and so this one's going to be heading down, so negative infinity. All right, same thing here. So this time we're coming from the right, so all of that's going to be a positive divided by, if I pick a number greater than 1, then this will be greater than 0 also. So that's going to be a very, very small positive number into into whatever a positive number. That's going to go to positive infinity, which are the same things that we saw on the graph. Okay, so there we go. Okay, so here we go. Vertical asymptotes. So if you have a non-zero over a 0, C is, x equals C is a vertical asymptote. Okay. If you have a 0 over 0, then C is a pole or or removable discontinuity. And so over here, I can make a little change and say that vertical asymptote, infinite limit, or non-removable continuity. Okay, so limit definition of a vertical asymptote then would be if either, like if I'm approaching C, so we'll write this. All right, so as the limit, so I'm going to say if the limit as x approaches C from the right of a function is plus or minus infinity, and the limit as x approaches C from the left of that same function is plus or minus infinity. Then x equals c is a vertical asymptote. Boom.